Hello, everybody. This is Nick Tiro, Professor of Information Technologies and Computer Science, Lakeland Community College. Let's talk about computer forensics, cyber forensics, digital forensics, whatever you want to call it. First of all, forensics is part of security, but the overall concept of digital security, information security, is a proactive approach to preventing something from happening. Forensics is a reactionary event. Something happened and you need to discover information about it. Now, let me give you a quick definition. I'll read it from a text just so we can work from the same point. It says basically, forensic science is accompanying the recovery, investigation, examination, and analysis of some digital device. Now, where digital forensics or cyber forensics breaks off from other forensics activities is we will often be asked to recover information from a device that we could potentially change, not just damage, but change it. For example, if I am not involved with crime law enforcement, but if a law enforcement investigator was to come into a fingerprint, right? They're going to gather that fingerprint. Now, they can potentially destroy that evidence by wiping the fingerprint or smudging it or something like that, but they really can't alter it where the fingerprint will actually change. But with digital forensics, one of the core principles is we have to make sure that what we're gathering is not changed, not even down to the bit level. Now, we can gather information, but we can't change that particular information. The other thing where digital forensics has been growing in the last 20 years is we are leaving a digital footprint, fingerprint, whatever you want to call it, on everything we do. I've said this for many years. We, as individuals, as consumers of technology, we are constantly balancing. We are balancing our privacy and information with some kind of convenience. For example, our cell phones, our smartphones, sorry. We have given up, and this is justifiably so, we have given up a lot of privacy so we can use a lot of the tools inside our cell phones. Our cell phones, our smartphones really, are constantly talking to the towers, right? If we want these smartphones to work, they have to be in constant contact with a tower, which means this cell phone is being tracked. Now, that is not nefarious. That is not the evil agencies tracking where we are. We're saying, I want to use this smartphone. I want to be able to make calls. I want to send texts. I want to use the internet. It has to use those cell towers, so it's constantly being tracked. It's constantly being pinged. We can discover a great deal of information from our cell phones, our computers. Every website we go to, every time we turn on the computer, every time we launch a program, every time we connect to a Wi-Fi, that is all information that the computer is storing. We hear about this concept called big data. That is the gathering of so much information and then working with that particular information. In cyber forensics, we are constantly digging deep into that information. We've got to make sure we don't alter it. And that's going to be a major concept as we talk about forensics, that we want to guarantee that what we're working with doesn't get altered. And one of the first things we do in digital forensics when it is possible, after we secured the equipment, after we brought it to a secure location, is we want to make sure that we work with a copy. Now, the beautiful thing with digital is we can make exact copies. Right? We'll talk about that in imaging and stuff like that in other videos, but we can make an exact copy, and then we can take the original copy and keep it safe. And we can do whatever we want with the copies, right? We mean multiple copies, and there's laws providing that. Again, I'm not an attorney, and I don't work with police departments or anything like that. But we can make it. We can take the original, make a copy of it, and just work with that given copy. But yet, there are things that we have to take into consideration. In this video, I just want to introduce a couple tools that you're going to see if you're taking the forensics course or you may hear about in other courses. So let me go up to my screen and let's take a quick look at a couple of these tools and why these tools are important to us and what they provide to us in a digital forensics environment. We're going to start with this one here. And I apologize that the size of my screen is not that big. This is a hash calculator. We use hash values all the time in the computer world, especially in forensics. What the hash value is, first of all, hashing is not encryption, right? Encryption, you take something, you convert it to something else, and then you can restore it back to its original form. A hash value is a one-way process. Basically, it is like a digital fingerprint, be careful using that term, or digital DNA. It basically says I can take a file and then I can ask the hash calculator or some kind of hash function to take the file and generate a signature or a code, and that code will be unique to that given file. I would not even be able to change one bit, bit, in that file without changing the hash files. So, as I said earlier, if I make a copy of an original item, whether it be an entire hard drive, a single file, a USB drive, or a phone, if I make a copy of that phone, I can first get a hash value of the original, and after I make the copy, that hash value will be identical to the original. So now I know that copy is a bit by bit, bit, down to the zeros and one, a bit by bit copy of that original, and I can use it. And in other demonstrations and in other videos, you will see me always going to some kind of hash calculation. So I'm always working with, I know I haven't changed that original. Again, we take a copy, we take the original and put it someplace else, and we can say, whether it be in a court of law or whether it be in a civil situation or in a corporate situation, this file is identical to the original. So we use hashing. Lots of discussion about hashing. All right, I'm going to move that there. The other program you'll see used oftentimes is this thing called this hex workshop or some kind of hex editor, HEX. And what this allows us to do, it allows us to drill deep into a file and look at the file on a bit by bit BIT level. This is what the internal lookings of that file may be. Now, sometimes we may use a hex workshop or this hex program to see if there's any hidden data in there, right? Stenography or something like that. We can potentially drill down and see if there's any hidden data in there. But we can also look, if you look right here, these first 2 bytes of this particular file, those are special bytes. That tells me what type of file this is. So if I was working with a Microsoft Word document or I was working with a PDF file, this one happens to be a PNG file. Those first 2 bytes, sometimes you refer to them as magic numbers, specifically identifies that file. So let's say, for example, I was to take a PDF file and I was to rename it to a .word document. If I look at it as just a file, it's going to say that's a Word document. But when I launch it, it's not going to open up Word. It's going to say it's corrupted. I can go in there and look if it's been changed, right? So these hex programs allowed us to look, and that's what I'm looking at right here. It allows us to look at a bit by bit, really byte by byte, of the internal workings of a given file. Access Data FTK Imager, very common tool that we use in forensics, in digital forensics. This tool allows me to make that identical copy. It allows me to copy an entire hard drive. It allows me to copy memory. If the machine is still up and running, I can launch this program from a USB drive and actually copy the memory. So if the machine got turned off, the memory is still secured from the copy. It allows me to do a copy of a hard drive. It allows me to do a copy of entire phones. Now, these copies are a bit bit-by-bit copy. So if I was to do a hash calculation on the original, hash calculations on the copy, they're going to be identical. So this is a very common tool that you use. It's like one of our first tools, because one of the first things we want to do after we secure that evidence is make sure that that evidence does not get changed. We make a copy of it so we can work only on the copy. Very common tool. And then finally, this is just kind of a gray screen, and I apologize for that. I'm going to shrink it down a little bit. This is a program called Autopsy, and what this does is allows me to build a forensic case. I can add evidence, and you're going to see in other videos how I use this. I could add evidence, I could add images, and what it will do, it will analyze those images for me, or analyze the different files for me and tell me when those files were created and what the hash values are. So it is an all-encompassing tool that we use in forensics. Now, one of the very interesting things about these given tools is they're open source. Now, there are some paid for tools. We don't use them in any classes at Lakeland. These are all open source tools that are regularly used inside a forensics analysis. So let's talk about a forensics analysis here. Generally speaking, we can look at a forensics analysis as a reactive event. And generally speaking, we can say it has to do with potentially a criminal investigation, maybe a crime, maybe you're working for a police department, maybe you're working for a private lab that works for a police department, and they are trying to gather criminal evidence that would be taken into court. Or we can do a forensics analysis on a potential civil event where it's not a criminal event, but maybe you're working for an organization and they're wondering maybe if somebody is doing something they're not supposed to do on their computer, or something happened in the computer and you're trying to figure out what potentially happened to it. Maybe the computer is constantly rebooting, or you suspect there's a virus or something like that. All of that is some kind of forensics analysis or forensics. So we have the criminal side where we're obviously looking for some information that we can provide. Now, we're not doing an investigation where we're a detective. We are just providing evidence, or we're providing documentation and analysis of given evidence. So maybe you have a photograph. Well, we as the forensics individuals may look at that photograph, and let's say that photograph has an individual in it. We can't say the photograph has the victim in it or the perpetrator in it. We would say there's an individual in there, and these are the information that I have with the photograph. If I take a photograph with a small phone, a small camera, or even with our phone, there is information within that phone, that the EXIF files, where it was taken, GPS information. Even if there's no GPS information, maybe we could potentially find out about that. On the civil side, we're often called into what is going on with this computer, or what is this individual is doing. For example, and I don't want to paint just a bleak picture or anything like that. Let's say, for example, a company has a policy in which you cannot surf the internet during work hours, and they suspect somebody is doing that. Well, that's not breaking the law. Surfing to the internet, let's say they're just going to Amazon.com or they're going to eBay and they're just surfing around. They're not breaking the law, but they're maybe breaking the company policy. So you may be called into looking up browser history. There could be, again, it's not breaking the law. Maybe people are, you're allowed to surf the internet from work, as long as it's on your lunch hour, but you can't go to an inappropriate site. Again, you're not breaking the law, you're breaking company policies. There can also be civil where it goes into a court situation. So again, you're not breaking the law. Unfortunately, if somebody is going through a divorce and they suspect maybe something wrong, infidelity on a phone or something like that, can I recover the text? Again, it's not breaking the law, but it's evidence that could be brought into a civil court. So it's a wide variety of items that forensics is used for. A couple years ago, Lakeland was a victim of a very serious cyber attack. Well, and forensics investigators had to come in and say, how did they get in? How did this attack happen? One, it's building evidence for if we ever capture those people, which we don't, they're international. But it also says, how can we protect into the future, right? This is what happened. I don't know what happened, but this is what happened, and maybe we can mitigate and prevent that from happening again. Forensics also has to deal a little bit with what they call open source investigation. Now, what open source investigation is, there are a wide variety of tools. Now, I just showed you simple tools on my computer, but there's a wide variety of tools up on the internet that you can use to do investigation. You can look up records. You can look up property records. You can look up court records. Now, you can't look up the specifics in a court, but you can look up docket information, personal property information, where somebody lives. That's referred to as open source investigation. Now, let me do a quick little demonstration about some open source investigation that kind of go, oh, that's interesting. All right, this is just one of those family pictures you take on a vacation, something you may see up on Facebook. This happens to be myself, my wife, and my son, and we're on a family vacation and we're someplace. Now, if I was to upload this to Facebook, Instagram, whatever, they will strip out that information. Facebook, Instagram, they strip out all that GPS information, all that EXFI information, but they do keep it. Again, digital evidence. They may strip it out so when they display it to individuals, the individual, even if I was to download this from Facebook or TikTok, it would not show me where this picture was taken, right? But they keep that, and so that's another part of that digital evidence. I want to discover where that picture was taken. Maybe I got it's another picture. I'm just using this as an example, but maybe it's another picture, and I'm not quite sure where that picture was taken. It's pretty touristy, so there's a good chance that we may be able to find out where this picture was taken. So I'm going to move this over. Sorry for the glitch there. I'm going to move this picture over. And all I'm going to do is, this is Google Photos, and I'm going to drag a copy of this photo, which has no EXIF file information. It has no GPS information, assuming I download it from Facebook or Instagram. And I'm going to drag it to over here. And I'm going to let Google Photos take a look at it. And it sits there and it grinds, and it discovered a whole bunch of points of interest. And lo and behold, it discovered, based upon information that Google gathered from other sites. You can see Google gathered all this picture from Instagram, and Instagram's a big one, X. And they said, I know where that picture is, where that picture was taken. And that picture was, don't ask me to pronounce this, the Gyeongbokgung Palace. It's the palace in Seoul, South Korea. That's interesting. This is part of what they call open source investigation. These are tools that are just open source, just means these are tools that are readily available. If I wanted to use Google Pictures, it's a common practice. Let's wrap some things up. So a lot going on with forensics, especially digital forensics. We are leaving a digital footprint, a digital fingerprint, a digital trail no matter where we're going. Let's use an example. I woke up this morning. I use an Echo Dot as an alarm clock. It woke up at a very specific time. I created a routine. That routine, that clock, is now part of the Amazon big data, right? So they keep that information. When I spoke to the Echo Dot and I turned it off, that's kept. When I turned my cell phone or my smartphone on, that information is now registered through my provider. My cell phone pinging the different towers tells me exactly where that cell phone was at, that smartphone was at. If I'm outside, a good GPS system, 10 to 15 feet. and even really good if it's a really clear day, not anything obstructing it in a field, you might be down to a meter or two. You start getting into buildings, you start getting into taller buildings in the city, all of a sudden that kind of expands it out because how the GPS, but it's fairly accurate. That GPS is fairly accurate. We give up some of our privacy for convenience. So the phone has to work. It has to talk to towers so it can tell me where I'm at. And that is constantly gathering that information, whether it's the provider gathering information or the phone is gathering information. So we leave that digital footprint. Years and years and years ago, forensics investigators would say, you enter a room, you're going to leave something behind, whether it's a footprint, maybe a thumbprint, maybe now DNA. It's the same thing. Think about, let's do a little experiment after this video. Think about all the technology you use on a given day, and then think about all the technology you use that you don't even think about. I have smart switches in my house. I turn those on, that's being recorded. I have a Ring bell, that's being recorded. All this stuff, what I mean by being recorded is it's digital, there's some kind of digital record in there. So very exciting field. Forensics, digital forensics, a very exciting field. Can be a little tedious at times, especially when we're drilling down into the bits and bytes and stuff like that, but very exciting, and it's just growing by leaps and bounds. So with that being said, let's go and learn something.